In this lesson, we're going to review the effect formula in Microsoft Excel. The effect formula is used to calculate the effective annual interest rate, and that differs from the nominal annual interest rate because it takes into consideration the compounding periods per year. The effective annual interest rate is the interest rate that's earned or paid over the life of an investment or a loan. It differs from the nominal interest rate because it takes into consideration that compounding, while the nominal interest rate does not. Therefore, the effective interest rate is actually higher than the nominal interest rate. Let's take a look at the formula in Microsoft Excel and the formula syntax. So as you can see on screen here, the formula is equals effect, and then we put in the nominal rate and Npery. The nominal rate is just the interest rate under the loan or the investment. The Npery is the number of compounding periods per year. If it's a 12-month investment or 12-month loan, and there's 12 payment periods, then it would be 12 compounding periods. We can also calculate the effective annual interest rate manually if we wanted to outside of Excel, and that would be equal to 1 plus I divided by n to the power of n minus 1. And n is the number of periods. For instance, if there's 12 months and it's just a 1-year loan, then the number of periods would be 12, and I is the nominal interest rate. So what's the interest rate under the loan? Let's take a look at an example on how we would calculate the nominal interest rate and the effective interest rate using Excel and also by doing it manually. So in our example, on January 1, 2020, Davidson & Co. acquired equipment through a loan for $1 million payable. The loan characteristics differ depending on the option selected December 31st of each year, with a market interest rate of between 8 and 12%. The goal here is to determine the effective annual interest rate under each of the scenarios. So if we take a look at the different scenarios in rows 27 through 30, we can see that scenario 1 has a nominal interest rate of 8%, and if you divide that by 12 for the 12 payment periods for the year, it translates into a rate per period of 0.667. Scenario 2 is 10% and 0.833 per period, and scenario 3 is 12% for the year or 1% per period. We calculate the effective annual interest rate under each of the scenarios in rows 38 and 37. 37 is doing it manually and 38 is doing it through Excel. As you can see, under each scenario, they're the exact same interest, which means that the manual and Excel calculations of the effective annual interest rate are the same, and it's calculated accurately. So in the first example, we know that the nominal interest rate is 0.667 per period. That is, it's 0.667, and that's the interest rate that's applied 12 times throughout the year. If we want to calculate the effective annual interest, it would be compounding each month. So let's take a look at the formula in the manual method. In cell E37, it's equal to 1 plus, and then we put in the nominal rate of 0.667 for the rate per period, and then we put that to the power of 12 periods and subtract 1. That gets us 8.3%. That's the effective annual interest rate, which is higher than the nominal rate due to compounding, and it results in 8.3 versus the nominal rate of 8. The effective annual interest rate under the Excel method is calculated by typing equals effect, open parentheses, putting in the nominal rate of 8% and the number of periods, which is 12. If we press enter, we can see that it's 8.3%. If we perform the same calculations, but with the data in scenarios 2 and 3, we can see that the effective annual interest rate in scenario 2 is 10.47%, and in scenario 3, it's 0.127%. Let's take a look at how that compounding works. Let's assume that we want to analyze scenario 1 in greater detail. Well, we have $1 million loan, so if I type in $1 million and we multiply that by 0.667%, we can see that the interest in period 1 is equal to $6,666.66. In period 2, if the loan is still outstanding, then the loan balance would be $1 million plus the $6,666.67, and that gives us a greater amount, and if I were to multiply that amount by the rate per period of 0.667, then I get interest for the period 2 of 6711.11. As you can see, the interest is growing as the loan balance increases. And that's essentially why, in this case, the effective annual interest rate is 8.3%, and it's not 8%, it's actually growing. If I were to change the number of payment periods to 2, I can see the interest per period is $40,000 and then $41,600. The total of those is $81,600. And if I were to take $81,600 and divide that by $1 million, then I get 8.16% versus the nominal interest rate of 8%. So that just goes to show how I'm able to back into the effective annual interest rate manually the long way, and proving that the effective annual interest rate in Excel is working accurately. Hey guys, thanks for watching this lesson. I hope you enjoyed it. And if you did, I'd really appreciate a like and subscribe from you. And if you want to learn more about Microsoft Excel, check out these videos above. And don't forget to check out our website, commercecurve.com, where we have lots of in-depth finance and accounting courses available with full training workbooks. All of our courses come with complete workbooks of lessons, examples, pre-built financial models, and training video. Hope to see you there.